Okay, so our main objective today is to find a line of best fit when you have a bunch of data plots, okay? Data points. So you're going to have something that looks like this graph with a scatter plot. And notice that the points aren't all on a line, and that's most like real life, okay? We're not all exactly even numbers and heights, right? We all have a decimal involved in our height, and most things in life are not perfectly measured out. So, the first basic thing you need to remember for this, first of all, is we need to be able to find a line between 2 points. So let's just review that really quick. First of all, we know that if we're going to find our slope for these 2 points, I would take m equal to -8 minus 1, so that's y2 minus y1. Yeah. Okay, so it's y2 minus y1 over x2 minus x1, which is 5 minus 2. So that would be -9 over 3, which is what? -3, right? Okay. So now we are going to use this, and I want you guys just to mark that off because I don't like the way it's written. I want you to write down y minus y of some point, so I'm going to sub number at p, okay, equals m times x minus x of some point. Okay? Yeah. It is, except that it says y2 minus y1 equals m times x2 minus x1. And really, you're going to leave the letter y and x in the formula, and you're replacing xp, yp, and m. Okay? So here, I want to find the equation of the line. I'm going to use this formula. I'm going to take my very first point. It doesn't matter. I could use the second one. You would still have a correct equation. Okay? So I'm going to say y minus 1 equals -3, which is our slope, times x minus 2. Okay? And then we would simplify it. So this would end up being -3x plus 6. Don't forget to multiply both of those by that -3. Okay? So y minus 1 equals that. And then I would add 1 to both sides. So my final equation would be y equals -3x plus 7. And that would be my equation. So in this next problem, we've been given a graph. It's a scatter plot. And we need to find a line of best fit. So what I'm going to do is make a line, and that line needs to go through a couple of my points, and it needs to be centered in the midst of all this, and try to eyeball it so it makes it in the center. I'm going to just kind of, you guys might get a different line than I do, but this is my line. Notice how it's kind of in the middle of all the data. Okay? Now, if you were to do this on a calculator and you were to tell your calculator to find your line of best fit, it would actually go through and try to minimize the distance of some of these points that are not on the line. So it would try to find a better fit. It may not be the same as yours. Okay? So I've got 2 points here that look like they're on the line, and what I need to do is estimate what those points are. Now, you'll notice on your homework today, you're going to totally have to estimate. What you have may not be what your partner has or somebody near you has, but it's going to be very, very close. Okay, it's an estimate. So what is this one? What's this point? What would you say that is? 2, 2? Okay, we'll call it 2, 2. How about this one right here? 3, 3. Okay, so we made our line of best fit. We found 2 points on it. Now we need to find our slope again. So our slope is going to be y2 minus y1 over x2 minus x1, which happens to be 1. Okay? So this is over 2, up 2. This is over 3, up 3. Yeah, it's on the line. I just eyeballed the line. I just took a line and tried to put it in there the best I could. Okay? All right, so now this one here, I'm going to use that formula again. We're going to use y minus yp equals m times x minus xp. So it doesn't matter which point I pick. I could pick 2, 2, or 3, 3. I'll just go ahead and do 2, 2. So y minus 2 equals 1 times x minus 2. Now if I solve that, it'll be 1x minus 2. I'm going to add 2 to both sides. So it'll be plus 2. And then it ends up being just y equals 1x. Okay? So you can see that's pretty close to what I have. I have a little bit of an intercept here. It's a fraction of some kind, but that's pretty close to what we have here. So that is my formula for that one. Question, yeah. So it's a slope of 1 and an intercept of 0. So it's, you know, it should be going through this and going up 1 over 1. So it's pretty close to that. It's an estimate. Okay? Yeah. Okay, so now let's look at the next problem here. This is more like a realistic problem. Okay? It says make a graph of the data, find the equation of a good linear model for this data, and predict when social welfare expenditures exceed 1,500 billion. Okay? This is all in billions over here. They shortened it. So we're really going to look at just that part of that. Okay? So, first thing we got to do is what? Graph it first. Okay? So graph all your points. Take a minute to do that. Okay, so you all should have something that looks like this. Notice that I cannot draw a straight line through all that. It would be kind of, it wouldn't be straight. So I'm going to pick 2 points to try to make it centered through. And it's going to look something like that. Okay? Okay, so the first point is one of my points. And I'll pick the next to last point for one of my points. So this one and this one. Okay? So it doesn't have to necessarily, yeah, you might pick another set of points. It's an estimate, okay? So first I need to find my slope. Okay? So M is equal to, oops, sorry about that, 1,000. Gotta get my pen again. 1,161 minus 146 over 21 minus 0. So if you put that in your calculator, I got 1,015 for the top and 21 on the bottom. Divided by 21, you get about 48.3. Okay? Okay, so we got our slope. We got 2 points, so we can make a line. Which point do you want to use for your line? The first one or the last one? First one? Okay, so y minus 146 is our y there, equals 48.3 times x minus 0. Okay, we need to simplify this out. We're going to multiply by 48 up over here, so it'll be 48.3x. And 48.3 times 0 is just 0, so I'm going to leave that out. And then I'm going to add 146 to both sides, so this will be plus 146 equals y. So now we have our line. And the very last step we're going to do is we're going to predict when social welfare expenditures will exceed. So is that my x value or my y value? Y. So I'm going to put in 1,500 equal to 48.3x plus 146 and solve for x. Okay? So if I subtract 146 from both sides, I end up with 1354. Now I divide by 48.3. I have 28 equals x. Okay? Well, it's not a perfect 28. It's 28.03, so I just rounded in. Okay, so 28 is my x. What is that x again? Years after 1970. So when's the actual year when the welfare expenditures will be above this amount? Yep, so 1970 plus 28, which is 1998. Okay? Okay, so basically, I'm not going to go through the next page, but I want to kind of run down a general thing that we've been doing. First thing you always have to do, graph scatter points. Graph scatter plot. Number 2, line of best fit. Okay, you got to find your line of best fit. That means pick 2 points. Okay, that means you're going to find your slope. And that means you're going to put it into the formula y minus yp equals m times x minus xp. Okay, then 3, then you're going to make a prediction. Usually, not all your problems will have a prediction, but a lot of them will. So they will give you something like what we did here. Okay. One last thing I want to talk about is extrapolation versus interpolation. Okay? In your homework today, it'll ask you what the difference is between them. Extrapolation, you can say the base word of this, part of the, well, not polation is the base word, but the outside of this is extra. So what does that tell you? You're making a prediction forward, or it could even be backward as long as it's not in the data that you're in. So you're extending your data out. You're extending your line past what you have. Okay? So that means so just think of it as an extension. Okay? Interpolation is really inside of the data that you already have. Okay? You're making a prediction inside what you already have. So think about inside, this is outside. Okay? Hopefully that will help you.